Good evening, everyone. Thanks for coming on a Sunday to spend time with us. And especially that shows the shout for open source and also what we are doing, the curiosity about what we are doing, and shows the interest in the linting as well. So thanks, Shini. Emma, thanks for a quick and very brisk presentation. So you started there very well. I hope I can carry on that momentum. Yeah. So yeah, I'm going to talk about arterial lint. That's when you talk about lint, the first thing that comes to your mind is arterial lint. So we'll have a look of what is arterial lint, and also with the GNAI, how that space is, what are the things happening, and then we'll move on to the custom lint. Why do we need custom lint in terms of systematic test benches? So right now, the de facto standard in terms of verification, the front-end verification is system Verilog and UVM. So why do we need custom lint in terms of those test benches? Of course, the bias lint. Thanks for the quick introduction from him on that. I'll take over from there to really show how extendable that platform is in terms of our vision and plan for a product line. Of course, I'll move on to BYOL variants, that is build your own linter variants. So what is in it for me, right? That will be answered over there for each and every one of you. I'll take you across sample results of our BOL, and of course with the summary, and I'll open the dice for Q&A. And anytime, please feel free to stop and ask questions. I'm okay to have discussions. So because this is a Sunday afternoon as well as it's an open source, so I would love to hear your ideas and suggestions and interactions. I'm pretty open. All right. So far so good. Yeah. So the moment you say lint, it is obviously audio lint. It's quite popular. When you talk about lint, okay, yeah, what you can think of it is naming guidelines and then coding style checks and maybe the synthesis and some mismatches. Those checks you want to focus on, and of course DFT. So for these kind of checks, it's quite popular and it is well documented, and also it comes with its own set of package rule sets. Right, popular ones are the RMM, reusable methodology manual, and then the 254 as well as start C, and so on. So with these checks, okay, is that enough? Okay, I run the checks. Is that enough? No. So basically, these checks are incorporated well into your development flow. That is a CI/CD flow. So you don't want these rules are very important. You can't really live without these rules. So those rules will also go into a gatekeeper. So no codes get checked then without these checks are being passed. So that's pretty standard and very aggressive, and also it shows the value of those rules. And RTL lint is dominated by commercial tools. You have the number one and pretty standard and long standing commercial tools in terms of your RTL lints. Okay, now, so the open source is gaining momentum, especially from Europe where we are, and we see from, as Shini mentioned, from spec to GDS, open source are gaining momentum. So it is the alternatives are becoming very available. At least I wouldn't say popular. It is available as of now. All right. So we have a momentum in terms of open source as in the space of lint. So what are the ingredients you need? There are a lot of very good GitHub projects are available in open source from experienced engineers as well as enthusiasts and hobby designers and students, of course, the learners who were learning the RTL design. So they put all their projects and then their enthusiastic learning in GitHub. And sometimes the funded projects like OpenTython and Pulp, and then the RISC-V process Shakti, all are available in GitHub to really share and learn and earn. So these rule sets, for example, in open source from low risk, it has a very well documented rule sets in terms of RTL. So okay, fine, I have the rules, I have the code. Then what has is printing me? You can run those lint checks and then find the issues. But here it requires a license. So being open source really helps to run those lint checks on your own without paying a bucks. All right, so that is there. Then what else is happening around us? If you look at it, there is a GenAI is getting right. You tell me, raise your hand if somebody doesn't hear about it or not curious about what is happening there. So for the generate code, okay, it generates code. Is it really right synthesis compatible? Or right, is the code is clean? You need the linters to clean up your GenA code. So the GenA is in one agent, and then right, the linter is another agent. So being a multi-agentic flow with the linters would help to really right offer a qualified code using your open source tools. So that's a space that's happening in terms of land on top of your innovation in right in open source. All right, that is on all about RTL length. Okay, and I can hear the shout from verification engineers saying, what about the test bench length? What are the challenges? Do we have any alternates? Historically, in verification and test bench length, this is a famous codes or right perspectives that I hear from right across not only in right Europe, India, everywhere. At least I had an opportunity to interact with many engineers. So first thing that came to my mind, right, what's the challenges in terms of test bench layer? That is the test bench is dynamic because it is so based, it's system very long, right? So the static link doesn't stand a chance. So now I would like to call it as a match. No, the system verilog parsers had all right, and you can do the linters using system verilog using open source tools. That's what I'm going to talk about in a little bit later. Give me a minute, and then the next complaint, or at least the challenge that I hear from engineers is they say SP parsers are very hard to develop and maintain. Yes, of course, commercially, right, there are parsers available, but it is very hard to develop open source, and especially to work with the EDA vendors to really to get a new role added. Now, it is status always high. It is very difficult. It is right. It's a mindset is one right size fits for all because we have rules. There's many rules. Okay, you can waiver, you can use it, but if I want a custom rule or something new that I want to add on, that is going to take its own time to on the convincing part. Okay, why you need the rule, and then how long it is going to be needed for the implementation of the rule, and then get the results out and then put it into your flow. Good. So far, so good, right? Is that hard? No, because when it comes to the rule set, okay, what is common? Agreed common, right? It is not very common. It is really very hard to come up with a set of common rules. Okay, which rules you want? Okay, I have this set of rules. Okay, performance. I had functionality. I have cosmetics, and these are rules very important for me. So how do you really define the common in terms of your rule set? That is a very hard challenge. And also, the other, at least not the least, but not the last as well, but there is another equally important reason that I hear from engineers are, right? So lack of good parsers, tools also, as well as API for newer languages like Python, Rust, right? All these new languages are being developed and supported in open source. How do you really, there's no documentation even, APIs to support these languages. All right, so that opens up into a new paradigm that is open source test bench length. So it is the length is a very old and proven concept, and this code analysis completely is changing the ball game. All right, so this open source test bench length provides the flexibility and also the customization options. Okay, I don't want to go for one size fit for all. No, I don't need all the rules. I just want only specific rules that make sense and meaning to me. I don't want to really run all the rules because it's available. Okay, the solution here is you build your own linter, and there is APIs that comes in the open systems bench lint, hello custom applications. You can choose, okay, static analysis you can do, or the lint you can do, and then you can add your own custom applications. Couple of them I'll walk you through over. All right, so this open source test bench lint also there are very nice, good parsers as well as APIs are available based on different languages. For example, like variable, that is a C++ based, implementation. That's a for good parser for linting from Google, and then SVLint, that's a Rust-based custom plugin for again test bench linting, and then there is PySlint, that's the Python-based package for linting, and it's basically it is overlay or under the hood. You have the slang and PySlang, which interacts with your PySlint API to develop your linters or system verilog parser, basically in this scenario. All right. So sad. Okay, I'm coming from a different domain, and then my products are now different, and my priorities are different. I'm right. There are different global teams. They have their own priorities and tastes, and then right set of guidelines. So how do we really solve using right one size fits all approach? So that's no more is going to fit here. So you need a custom linting. So your priorities and preferences are different. You can customize that. You can set the configuration in custom linting, saying, okay, these are the roles I want. This is my high priority. So compatibility, right? So, as a team sitting in Bangalore, compatibility is more important. And then right, same in Israel, the reusability can be different. And then I have a set of CAD team who's really interested in debug, and sometimes it's naming for the customer to look to make the code look very nice. You need the naming guidelines, and then the functionality. Yeah. So when you go for different variants in a very quick time to market pressure is more. The functionality is critical. I don't want to slack. So those rules are important for me. How do I accommodate all these requirements in terms of priority and preferences? That can be actually using configurations using your BYOL or the custom linked. All right. So you can group these categories in terms of your based on your purpose. So the popular ones I listed here, and also the size, the priority and preference you can accommodate as you want. At the end of the day, you will have a pie that will solve your problem. And the configuration basically control the aspect of your rules, right? Okay, this is the waiver mechanism, or these are the set of rules I want. Check in, right, for a regression run. You can go for all these customizations and enable and disable features of your rules in custom linting. All right. So let's move on to static analysis of system alert test bench. Any questions so far? All right. All right. So I'll walk you through the system alert test bench linter that is based on bias lint. We have two categories of lints here. We have qualitative applications and quantitative applications. In qualitative, uh, basically that covers the naming and style, and as well as the functional rules, as well as the reusability of your rules, right? So those comes under qualitative, and debug, of course, compatibility, all this comes into qualitative. Then what about quantitative? So in quantitative, there are few applications that we experimented, and then yes, that is right room for open invitation in terms of collaboration. Yeah, of course, we are working on a couple of them internally in right in our R&D, but it may right the priority and the release depends on right our team's bandwidth. But if anything that is interesting to you or you want to really come up, yeah, we are open to innovation on that front. So on the quantitative applications, we have SVA density and then FCOV density. So yeah, so when we talk about SVA density, okay, how much assertion is enough, how much is present, what kind of properties you have, what kind of sequences you have, and how many numbers of sequences you have, right? And then the complexity of that. So we can walk through vertically as well as horizontally. So that's one application, right? The quantitative application that comes under bias length. So the basically the size and dice of right how much you want, how right what is it that you want can be done with an interaction with our team and then take it forward. The same way, right? There is one more application that's FCOV that is specifically targeting on coverage, function coverage. All right. So our product line based on bias length, we have multiple lengths, starting from UVM length, and then move. We have SVA length, which is focusing on system level assertions, and then EMU length, that is specifically targeted for emulation rules. And then we have safety critical rules that is under safety rules. And of course, when we talk about system level assertions, then formal. We have the formal verification lengths as well. And it is then the obvious question is, all this is meant for ASIC. What about FPGA? We do have FPGA length. So what is applicable in ASIC may not be really suitable for FPGA, or you need a very specific focus FPGA rules that you want to check. That is feasible using our FPGA length. All right. So here's our sample BOL variant. That is a build your own linter. So we have our team, and myself and my team. Um, we developed the BOL, which is meant for UVM lint core, that is available as a base class library. Right? Of course, I hope all of at least majority of you are using UVM. So this rules set that are specifically targeted for the core library. And then we have another variant called SVCK, the system allow OOP check as set of rules on length. And then for synthesis, we have the UUL length, which is targeted for the uses. It's a system allow RTL for length for uses. And then this is RTL friendly. This is an open source way. We talked about the RTL length, right, in an open source way. And then we have very later SVA length. The support for SVA in terms of the later is coming improving, and then it supports I think sometime back news came out, and then the support is really improving. So in order to really maintain the compatibility, we developed a SVA length, which is compatible with very later. A lot. So when I talk about compatibility, yeah, okay, my code base, my IP is running with one tool. What about, if I migrate to another tool? So what are the features that, do I need to count on the features and then ambiguities? And then, I want to seamlessly make sure that, okay, my code, runs across different tools. So we do have the compatibility checks as a package in terms of length rules. For example, we have the SPA support across the formal tools and also SV 2023 features across the commercial tools. All right, so that's in terms of product line. And then what do we have? I move on to the BYOL across platforms. Yes, Test Bench Lint is our base product, which is implemented in multiple parsers, as you can see, using commercial parsers as well as slang variable. So then what are the different variants of lints that we have as of today? In slang, we have system alert test bench, constraint, as well as UVM lint. Of course, added to that DPI, FCOW, as well as system alert assertions. So if you are a slang user or you wanted to have your own linter to be implemented in using slang, so these waivers, we support you and be in touch with our team for any deployment or any request if you are planning to move on this direction. All right. So if I'm not a slang user, I'm particularly interested in variable. Yes, of course, we can do that. We have two lints as of today based on variable, that is SVA length as well as SVCK. So SVCK is a very specific one, which is a niche one, which is OOP rules. Just very sleek one. Okay. Yeah, just drop your mail if you're interested. And on commercial process, we have SVA rules. I think that is the main focus of today's talk. So later part of the day, Shini will walk you on the SVA rules and then, what are the rules that you want? And then if you have any requests in terms of, okay, this is the rule I want to really see, has implemented. Yeah, break pop in your request, we'll take up. And if you want any deep technical discussion on any of this, either drop a mail or just message me or ping me. Myself and Shini will be happy to really take this forward. All right. So is that all enough? No. Okay, I talked about the results and summary. So, okay, here is a sample snapshot of the linking summary for UVM lint on IEEE 1800.4 BCL, the core. So if you look at it, I listed a couple of very important rules, That is, so every day you're using your base classes, UVM libraries. Your library itself is having this many issues, You see the number of violations. The debug method missing end label.
There's a lag.
Sorry?
There's a latency on the slides. You don't see that UVM lint core rules yet. Can you please
Is
check?
there a problem?
Not from see my the BYOL platform.
Yeah. No. Okay, let me stop sharing and then again share. That may sometimes solve that issue.
This is much better. Yeah. Thank you.
Yes. Thank you.
Yes.
Yeah, right. So yeah. This is where the result that I'm talking about on the right, the UVM Mint results on your IEEE 1800.2, right, the core. Okay, it's very interesting and surprising. Yeah, digest this. If you have any questions, please, right, be in touch with us. All right. So the open source suspension thing, it's an exciting, right, space, and a lot of things are happening. So the open source can lead the way rather than really, right, just do a catch-up game with the commercial tools. And especially open source, it is the turnaround time is faster. You, okay, say this is a spec for the new rule. Yeah, it can be implemented anywhere from 30 minutes to 2 days. It depends on the complexity, right? So, and of course, the team's availability as well. So, uh, open source can be right potential for vast set of developers. I see a lot of young talents, and then people are interested in, okay, yeah, this is where I want to be part of this. Yes, there's a lot of room for innovate. And then, right, so here's an open invitation for the innovation, right, on in terms of rule specs or anything that you want to see, even an application. So reach out to us and then keep right looped us on anything that you want. And also, right, keep connected with us to know more on what is happening in this space. Yeah, I open the dice for any questions.
So thank you, Ajeetha.
Thank you, everyone.
Hello.
Thank you, Shini.